just once again, check out raysummit.org to see what's going on there. I hope you all will join us. And now we'll switch to our brief QA and panel discussion. We've gone a little long today, so we'll just take this for a short time. So I'll ask our speakers to join us again with their video and audio so we can have a discussion. All right, let me ask just a general question for the panel, and then as we have time, we'll take the rest of the questions still in the Q&A feature. And that is, as you guys, gals, think about the problem of ML ops, the kind of tools you've been building and so forth, what are some areas where you think there really ought to be a solution that's just general, that works for everybody, whether it's tools or APIs or whatever? When you think about the problems of just getting stuff into production and reliable, what do you think just needs to be solved, and we can solve it?
Yeah, I guess I can kick it off. I think one of the sort of common thread among all the three talks today is sort of how we're building library that tailored to data scientists, not just software engineer, especially not just system engineers. Like data scientists are a different group of sort of scientists that have like ability to write program, but have specialties in mathematics and more or less the kind of theoretical work. So this means oftentimes they will appreciate a different set of APIs that I would hope is already solved today, but it seems to be still unsolved problem.
Yeah, I agree with that. And I've also seen a lot of data scientists from, like I mentioned in my talk, they're from like different backgrounds, right? And from physics and medicine, and people there, like they generally pretty good at, know what they're doing and know what kind of tasks they need to do, but they're not really good at scaling and all these tasks. So, if it's a long pipeline that you need to deliver the model and go all the way down, that can be, it's just like, your iteration time is really long. And on the other hand, if you enable people to do more just with pure Python, that itself feels like very powerful to me.
Maybe related to that, Ding Ding, is when you guys were working with SK Telecom, were there particular features of Analytics Zoo that really made that project a lot easier than if you had to roll a lot of stuff by hand? Anything that comes to mind about that? I'm thinking, for example, when like ingesting data is a real common problem in standard pipelines. It's one thing to build a great model, but how do you get the data in? How do you keep it secure? What are some of the things that Analytics Zoo can help in that area, or some of the others that you worked with?
For the SK Telecom, their data was stored in HDFS, and in their previous solution, they use TensorFlow to train their model, and they need move the data from HDFS to the GPU, and it brings huge overhead. And with Analytics Zoo, they can run their TensorFlow model in Analytics Zoo, and Analytics Zoo can read the data directly from the HDFS, and we can build an end-to-end pipeline, and it's very efficient.
Cool. Let me answer a couple of questions from the audience just quickly. Someone asked, can RayTune be used to influence the hyperparameter search as it progresses? That is something that's built into RayTune. Some of the algorithms do try to learn as they're learning and optimize the choice. So-called Bayesian approaches do this. There's also another one whose name is escaping me, and I just did a tutorial on it recently. But anyway, there are features in there for that. The other question in general, how do I integrate? Well, there's telecom data, satellite data, and I want to use deep learning with Ray. One of the things we learned building Ray is that it's better to integrate with really good tools. So for example, if you're trying to train a satellite to do something, you can use the reinforcement learning library ROLib with PyTorch or TensorFlow for deep learning, RayTune for training with some of these other algorithms, and it's designed to be an integration framework as much as anything. What are some of the things that are coming in Serve that you think will be very helpful for people to know about as they're thinking about model serving?
Right, yes. So for Serve, we're sort of hardening this concept of doing a very good application level autoscaling. Currently, all the solutions out there are scaling based on, say, CPU load, GPU load, or memory load, which is not sort of, it works in general, but then it's typically like kind of slow to react to changes, as well as sort of not like pretty costly in many cases. So research right now, we're working on very intelligent application level autoscaling, sort of scale based on the queues, scale based on the incoming load, and like figuring out what's the best way to scale up as well as scale down, because deep learning and machine learning model are often expensive. And if you don't need the hardware, we would very much like to scale it down so that we can free up the resource.
And I want to thank everybody for coming. Check out the videos later. I'll post a blog to anyscale.com with the links. And do check out racesummit.org for information about Race Summit. Thank you so much for our speakers. I really appreciated your time and energy, and I hope to see you all again soon.